Okay, the first theorem is called congruent corresponding chord theorem. Congruent corresponding chord theorem. And then we have perpendicular chord bisector theorem. I left space because I'm going to draw it in between. Okay, so for each of these, I'm going to draw a circle as best I can. Not too bad. Okay, so for the first circle, we have a center, of course. Here's the center. And then we're going to draw two chords that are about the same length. So here's two chords. And this theorem states that if these chords are the same length, then this arc is the same length as this arc. AV, please be quiet. Okay. Then we have perpendicular chord bisector theorem. Of course, we have center again. And let's say we have a chord over here. And a diameter right here. Okay, if this diameter is perpendicular to the chord, then it bisects the chord, meaning that this is the same length as this, and also this arc is the same length as this arc. Okay, so that's the two main ideas for the page, and now we'll look at the examples. Okay, so the first one, it wants to know the measure of this arc right here. This central angle is 75, so this would be 75. This chord, it's showing the same length as this chord, so therefore this arc would be 75 degrees. So arc AB is 75 degrees. Okay, number 2, same concept. It shows two chords, it shows the degree measure the same, it shows that one chord's 5, so the other chord would also be 5. So segment UV is 5. Okay, then this one right here. It shows the radius the same, so these two circles are congruent. It shows that this arc right here is 104, and so is this, so that means that this is the same length as this chord, so QR equals 11. Then number 4 is a little bit trickier. It shows two chords, so it shows one right here, and another one right there that's the same length. So if this chord and this chord are the same length, that means this arc is the same as this arc over here. So you can do 110 plus 60 to get 170 for this arc, and that would have to be the same as this arc. So arc ZYX is 170 degrees. Okay. So the next set of problems is based on this idea, where if the diameter is perpendicular to the chord, then it bisects it. So over here for number 5, shows the diameter perpendicular to this chord, so then x would also equal 8. Then for number 6, same idea, diameter is perpendicular, so this is the same as this, and this arc is the same here, so x equals 40 degrees. Number 7, same idea, this would be equal to this, so we can do 5x plus 2 equals 7x minus 12. We'll solve for x.
7.
X equals 7. And then from here, we're going to go to the back of the page. So once you're done writing, just flip to the back. Okay, so we're going to do number 13 and 14. There's a few more steps in 13 and 14 than the other problems had. There is a new theorem for this as well, so we're going to write it down. Equidistant chord theorem. Equidistant chord theorem. So here's a circle. Here's the center. I have two chords, maybe one right here. And maybe one right here. Okay, so this equidistant chord theorem, if the chords are the same distance from the center, so from here to here is the same length as from here to here, then the chords are also the same length. So this chord would be equal to this one, and then also the arc right here would be equal to this arc over here. And then also note that when you have this perpendicular right here, it bisects that chord, so you have that as well. Oh, it's kind of crooked, sorry. Okay, so then applying that to the problems over here, number 13 says find the radius of circle Q. Okay, we'll get to the radius in a second, but before we do that, we need to find out what x is and what these lengths are right here. The way to do that would be to set these equal and solve for x. Okay, we got x equals 3 so far. I'm going to plug this back in so I can find this length. So I just found that this is 15 and this is 15. Okay, so this problem wants the radius. And what we do to find the radius is, so like this is the center. We draw a line from the center to this point here. That would be the radius. But what you also have is a right triangle right here. So you can use that right triangle to find that length. It shows that chord's 16, so half of that chord would be 8. And then we can do 8 squared plus 15 squared equals c squared to find the radius. So we got c equals 17. So the radius is 17. Next, 14. Okay, 14, same idea. We're trying to find the radius. So if you draw a line from the center to this point, that would be the radius. And then you have a right triangle right there. The only thing is you have the 5, but you don't know how long this length is. So we're going to solve for x. 4x plus 4 equals 6x minus 6. X equals 5. Plug that in. Okay, it comes out to 24. So that's the length of this whole thing is 24. So half of that would be 12, so this length is 12. So then you can do 5 squared plus 12 squared equals c squared. Okay, so now I'm going to give you the rest of the class to start your homework. Please let me know if you have questions with the homework on Schoology, and then if you finish that, work on Khan Academy.